You're standing in a well-stocked kitchen holding two pieces of raw meat. One is beef, the other is lion. Both look roughly the same, red, marbled, unremarkable. Your instinct probably tells you the lion is somehow more dangerous to eat, even though you couldn't explain exactly why if someone pushed you on it. Here's the thing nobody tells you about that instinct. It's not superstition, and it's not squeamishness. It's a genuinely accurate read on a real, measurable danger, one that has killed explorers, poisoned entire survival expeditions, and shaped dietary taboos across cultures with zero contact with each other. So let's actually answer the question properly. Why can't we eat predator meat? And did ancient humans already know something about this that we've mostly forgotten? Let's start with the basic ecological math, because the answer begins with something considerably simpler than biology. It begins with energy. Every time energy moves up one level of a food chain, from plant to plant eater or from plant eater to meat eater, roughly 90% of it is lost along the way, burned off as heat, spent on movement, simply wasted in the messy business of being alive. Ecologists call this the 10% rule, and it means every additional step up the food chain leaves you with dramatically less usable energy and dramatically fewer individual animals to hunt. A patch of grassland can support enormous numbers of grazing animals. Those grazing animals can support a much smaller number of predators. And any predator eating those predators, an apex predator on top of an apex predator, becomes vanishingly rare almost by mathematical necessity. Lions aren't just intimidating, they're ecologically expensive, representing the concentrated tip of an enormous pyramid of energy that took a huge number of other lives to build. Which means, on pure economics alone, predator meat was never going to be an efficient, reliable food source for ancient humans, even setting aside the actual physical danger of trying to hunt one down in the first place. But scarcity and danger during the hunt are only part of the story. The deeper, stranger problem shows up after the hunt succeeds, sitting quietly inside the meat itself, and it comes down to a concept called bioaccumulation. Here's how it works. Certain substances, heavy metals, specific toxins, and certain fat-soluble vitamins don't break down easily and don't pass through an animal's body quickly. Instead, they build up, stored primarily in fat and in the liver, accumulating steadily over an animal's entire lifetime. A plant absorbs a small amount of a given substance from its environment. A herbivore eating large quantities of that plant across its life concentrates that substance further, and a predator eating many herbivores across years of hunting concentrates it again, and again, and again. By the time you reach the top of a food chain, an apex predator can be carrying a concentration of certain substances that's dramatically higher, sometimes by orders of magnitude, than what existed at the base of that same food chain. This is called biomagnification, and it means the animal sitting at the very top of the food pyramid isn't simply the most impressive one to look at. It's also, quietly, the most concentrated storage container for whatever toxic or overloaded substances have been steadily working their way upward through every single meal that animal ever ate. Nowhere does this show up more dramatically, or more historically documented, than in a single organ from a single Arctic predator: the liver of a polar bear. In 1597, a Dutch expedition led by Willem Barents, searching for a northern sailing route to Asia, found their ship trapped in Arctic ice, running low on food, and surrounded by polar bears. Desperate, the crew killed one and cooked its liver. Within hours, several crew members became violently ill. Their skin began peeling away in sheets, from their feet all the way up to their heads. They suffered crushing headaches, vertigo, and vomiting so severe that the surviving crew genuinely believed some of their companions were going to die. What the Barents crew had stumbled into, without any way of understanding it, was a textbook case of hypervitaminosis A, catastrophic vitamin A poisoning. Polar bears eat seals almost exclusively, and seals themselves are carnivorous animals that store vitamin A in enormous quantities in their own livers. When a polar bear eats seal after seal, year after year, all of that concentrated vitamin A accumulates further, stored specifically in the bear's liver, until it reaches levels that would be genuinely toxic, sometimes fatal, to a human being eating even a modest serving. A few ounces is enough to cause severe poisoning. It's not a large quantity, it's an extraordinarily concentrated one. Here's the detail that should genuinely change how you think about this. Indigenous Arctic peoples, including groups across Siberia, Alaska, and northern Canada, had already identified and avoided polar bear liver as a deliberate, deeply ingrained dietary taboo, long before any European explorer ever set foot in the region. They ate the rest of the animal freely, the meat, the fat, everything else the bear's body offered. The liver specifically was set aside as dangerous, a rule passed down and followed consistently across communities that had clearly learned this lesson the hard way, at some point in the deep past, and then carried that knowledge forward carefully enough that it never had to be relearned through tragedy again. European explorers, arriving centuries later and dismissing the local knowledge as unfounded superstition, paid for that dismissal directly. This same danger followed explorers for centuries afterward. Later Antarctic expeditions faced comparable poisoning from the livers of sled dogs that had themselves been fed seal meat, the same concentrated toxin working its way up yet another link in the same basic chain. That's the honest, uncomfortable pause worth sitting with here. This wasn't an isolated, one-time historical accident. It was a pattern, recognized independently by people separated by vast distances and centuries, all converging on the same practical rule. Whatever you do, don't eat the predator's liver. Vitamin A poisoning is dramatic, but it's not the only danger hiding inside predator meat, and the second threat is considerably more universal, showing up across climates, species, and continents, rather than being confined to one specific Arctic story. Trichinosis is caused by a parasitic roundworm called Trichinella, and it spreads specifically through the consumption of raw or undercooked meat carrying the parasite's larvae. According to data collected by the CDC, meats carrying genuine risk of harboring this parasite include bear, wild boar, fox, wolf, walrus, and seal, which is to say, overwhelmingly carnivorous or scavenging species rather than typical grazing herbivores. Recent CDC surveillance data covering trichinellosis outbreaks in the United States between 2016 and 2022 found that bear meat was the suspected or confirmed source in the majority of reported cases. Studies of wild bear populations across Canada and Alaska have found Trichinella infection rates ranging from roughly 1% up to 24%, and infection rates climb even higher among species that hunt and scavenge more exclusively, the strict carnivores sitting furthest up the food chain. The underlying mechanism here follows the exact same basic logic as the vitamin A problem, just with a living parasite instead of an overloaded vitamin. Predators eat other animals that are already infected, and the parasite simply continues its life cycle inside the new host, passed forward every time one meat eater eats another. Researchers studying this pattern refer to it as a sylvatic cycle, an ongoing chain of infection circulating specifically among wild carnivores and scavengers, occasionally spilling over into omnivorous species like wild boar when they scavenge an infected carcass, and from there, eventually, into humans. Herbivores, by contrast, are largely insulated from this specific cycle in the first place, because the parasite depends entirely on meat-to-meat transmission to survive and spread. An animal that only eats plants was never part of that particular chain to begin with. Put these two mechanisms together, concentrated toxins building up through biomagnification, and parasites circulating specifically through carnivore-to-carnivore transmission, and a clear, unified picture starts to emerge. The further up the food chain a given animal sits, the more concentrated danger tends to be riding along inside its tissue, layered on top of whatever ordinary risk already comes with hunting something powerful enough to have made it to the very top of that food chain in the first place. Which brings us back to ancient humans specifically, and here the honest archaeological answer requires real care, because we don't have a Paleolithic field guide explicitly listing which animals were considered dangerous to eat and why. What we do have is strong, indirect evidence, and it points in a remarkably consistent direction. Traditional diets, documented across hunter-gatherer societies worldwide, overwhelmingly favor herbivores, grazing and browsing animals sitting comfortably in the middle of the food chain, over the apex predators sharing the same landscape. Lions, wolves, and large cats generally do not appear as staple everyday food sources in the archaeological or ethnographic record, even in regions where these predators were common, dangerous, and, by any reasonable measure, occasionally directly competing with humans for the exact same prey animals. That absence is genuinely telling. Ancient humans weren't avoiding predator meat purely because it was hard to obtain, though it certainly was that too. They very plausibly avoided it because, across countless individual encounters spread over an enormous span of time, some meaningful number of people who did eat it got sick or worse, and that hard, expensive lesson was gradually folded into culture, into taboo, into the kind of practical rule a group simply stops questioning because the cost of testing it again is too high. This is precisely the same mechanism responsible for the polar bear liver taboo among Arctic peoples, just operating on a considerably larger and older scale. You don't need functioning knowledge of biomagnification or parasitology to arrive at a genuinely correct life-saving rule. You simply need enough repeated, painful experience, passed forward carefully enough across generations, until the rule survives long after anyone remembers precisely why it started in the first place. Somebody, at some point, got violently sick after eating a predator's liver or a predator's undercooked flesh, and somebody else was paying close enough attention to notice the pattern and to make certain the lesson didn't have to be relearned by someone else's suffering all over again. So why can't we eat predator meat? At least not casually, not routinely, not the way we eat cattle or deer or fish. The honest answer runs through pure ecological math, through the simple, brutal fact that apex predators are ecologically rare and metabolically expensive by their very design. It runs through the specific, dramatic danger of biomagnification, concentrated toxins quietly accumulating at the very top of a food pyramid, waiting inside a liver that looks, on the surface, exactly like any other organ. And it runs through the ongoing, active danger of parasites that specifically depend on meat-eater to meat-eater transmission to keep circulating at all, riding forward from one apex predator's meal to the next. Ancient humans very likely never had the vocabulary for any of this. They had no concept of vitamin A, no framework for parasitic life cycles, no scientific model of trophic levels or energy pyramids. But they had something arguably just as effective. They had pattern recognition repeated across countless individual lives and refined patiently across countless generations, and they had a culture genuinely capable of preserving a hard-won, life-saving lesson long enough to protect the people who came next. People who would never have to personally rediscover, through their own suffering, exactly why the animal at the very top of the food chain was never actually meant to be on the menu.